This video is on Pythagoras' theorem. So Pythagoras is the name of the man who discovered all of this, and it's all to do with finding the length of a side in a right angle triangle if you know the other two sides. So you square the two sides that you do know, then either add or subtract depending on whether you're looking the long side or the short side. So you add if you're looking for the long side, which is the hypotenuse opposite the right angle, or subtract if you're looking for the short side, one of the two shorter sides, and then square root at the end to get your answer. If you follow these three easy steps, then that will find you the length of a missing side in a right angle triangle. So it only works for right angle triangles. It's got nothing at all to do with the angles totaling up to 180 or anything like that. So question 1, a rectangular field ABCD is shown. The length of the field is 180 metres and the width of the field is 75. Calculate the length of the diagonal BD. So they're wanting the length of this side. So first of all, if you just split it up, well, the way they've got it split up with the diagonal there, you have got two right angle triangles. So the one at the bottom, if there's 160 metres at the top, there'll be 160 metres at the bottom as well. So following the three steps for Pythagoras, the first thing you do is square the sides. So take 160 and square it. So do 160 times 160, or 160 and then your squared button, and you get 25,600. Then take the 75 and square it. So 75 squared gets you 5,625. And then you have to decide whether you add or subtract. So because you're looking the slanty side, that's the longest side in the triangle. These two here are the shorter sides. So the one opposite the right angle is your hypotenuse, and you add if you're looking to find your hypotenuse. So you add those two together. That gets you 31,225, and then the last step is square root that, which will get you 176.7 to 1 decimal place metres. So the length of that hypotenuse is 176.7 metres. So if you square that side, add them together, square root, and that will find you the length of that diagonal. Number 2. A support for a flagpole is attached at a height of 3 metres and is fixed to the ground 1.2 metres from the base. Calculate the length of the support marked X on the diagram. So again, we're wanting to find the length of the slanty side. So take each of the sides and square them. So take the 3 and square it. 3 times 3, 9. Take the 1.2 and square it. So 1.2 squared is 1.44. And then again, the side that you're looking is the hypotenuse, the longest side. So add those two together will get you 10.44. And then square root the 10.44 will get you 3.23, or 3.2 metres if you do it to 1 decimal place. Number 3, ABC is a right angle triangle. AB is 15, AC is 17. Calculate the length of the side BC. So they're wanting this side here. So you take each of the sides and square them. So take 17 and square it. So 17 squared, 17 times 17, 289. Take the 15 and square it, 225. This time you're not wanting the hypotenuse. The hypotenuse is the longest side, the slanty one. You're wanting this one here, which is one of the shorter sides. This one and this one are two shorter sides. So whenever you're looking one of those, you subtract those two answers. So you do 289 take away 225, gets you 64. And then the square root of 64 means what times what? Gets you 64, which is 8 centimetres. They sometimes ask you to do this without a calculator, but they'll not give you numbers that are too difficult. It'll be numbers that you know how to square and numbers that you're able to square root, or else it'll say leave your answer as a square root. Question 4 then. This time we've got a grid coordinates. So the diagram shows the points A, which are 1, 3, and then B is 10, 5. Calculate the distance AB, so they're wanting you to find the length of this slanty side and give your answer to 2 decimal places. So before you can do anything with Pythagoras here, you need to actually make it into a right angle triangle. So that side there would be the hypotenuse, and then just go down and across, and you've got yourself a right angle triangle with the right angle down there. So the difference with this one, then, you need to actually work out what the distance is across and the distance going up, because it doesn't tell you. So the distance up is 2 squares. The distance across is going from 1 up to 9, or sorry, 1 up to 10, so it's 9 squares or 9 centimetres. So take it one number at a time, so take the 9 and square it. 9 squared, 9 times 9, 81. Then take the 2 and square it. 2 squared is 4. And then you're wanting the hypotenuse opposite the right angle, so add those two answers together would get you 85, and then the square root of 85. So I was able to do that so far without a calculator, so you could easily get something like that on the non-calculator paper. And then square root 85 at the end would get you 9.2, and it said 2 decimal places, it goes 2195, so cut it off to 2 decimal places would mean cutting it off there, and you get 9.22 centimetres. Okay, question 5, calculate the area of the triangle. So area of a triangle is base times height divided by 2, and the base is the distance going across, and the height is the perpendicular distance going up. We don't have that distance going up, we don't know what that is. So in this question then you're able to use Pythagoras to get the height first, and then use your area formula. So using Pythagoras then, you would square both of the sides, so take the 8.2 and square it. So 8.2 times 8.2, or 8.2 squared, gets you 67.24. And then take the 6.4 and square it, so 6.4 squared gets you 40.96. And you're looking one of the shorter sides here, so that's the hypotenuse, these two are the shorter ones, so you subtract those two answers. So do 67.24, take away 40.96, and you get 26.28. If you take these away the other way around, you'll get a negative number, which you'll not be able to square root, so if that happens, just put them in with the big number first. So the square root of 26.28 gets you 5.126, so maybe round that to 2 decimal places, 5.13. So that's the height that we're going to use, that's the height of the triangle. So then you can go and use the area formula. Base is 6.4 times a height of 5.2, and then divide by 2 because a triangle is half of a rectangle, so 6.4 times 5.2 divided by 2 gets you 16.64, and this is all in centimetres, so your area answer would be centimetres squared for the units of measurement.